Hey Ramblers, this video is going to deal with chapter 4.6, which deals with the concept of slope. Now, slope is something that's probably very familiar to you and something you probably learned as early as 6th or 7th grade. But it's really important in math, and it's going to be a central concept right on through calculus and beyond. So we'll review the formula of how to find it, and we'll talk a little bit about how to just get a ballpark idea of a slope just from looking at it on a coordinate plane. We'll also discuss how to find the slope of parallel lines and perpendicular lines. So take good notes. Even though it is familiar territory, make sure that you review this stuff because it's so important to us here in geometry, but also beyond until your later classes. Okay, thanks for watching. Let's take a look at a segment on the coordinate plane. You'll recall that the coordinate plane was developed by René Descartes, and so it is also called the Cartesian plane. Well, here, we're not concerned so much with the length of PQ, although that may be important in later geometry called analytic geometry. Right now we're concerned with the change in the x-coordinate of P and the y-coordinate of P versus the x-coordinate and y-coordinate of Q. In other words, how much is y changing as x changes? And that ratio is known as the rise to the run. That change in y is known as the rise, and the change in x is known as the run. And it yields a formula that you've probably been introduced to already called the slope formula. So if I were to generalize the coordinate of q as x sub 2 and y sub 2, and I generalized the coordinate of p as x sub 1, y sub 1, the calculation of the change in their values would be slope. So the change in the vertical would be in the numerator, and the change in the horizontal would be in the denominator. So to find that change, we simply subtract the y-coordinate of P from the y-coordinate of Q in the numerator, and the x-coordinate of P from the x-coordinate of Q in the denominator. That will give us rise over run. Now, it's really not important that P come first or P come second, just that you keep the order consistent. So if you want to use the coordinates of Q as the second and P as the first, that's fine. You'll get the same answer. All right, so let's get away from the general and let's look at specific values. So here, point P is at 2, 2, and point Q is at 6, 6. And you can see that if I calculate 6 minus 2 divided by 6 minus 2, the ratio would be 1. Well, suppose that I change point Q and I put it at, let's say, 6, 4. You'll notice that because the increase in the rise is not as great, we'll have a smaller slope. Now, my change in the vertical is going from 2 to 4, or 2 places, while my horizontal has not changed. So I have a smaller slope. If I change the horizontal and make it steeper again, you'll see that I can return the slope to its original value of 1 because the change in y is 2 and the change in x is 2. It really doesn't matter where on the coordinate plane I calculate this, because so long as the ratio is the same, it doesn't matter where on the coordinate plane my segment is. All right, let's take a look at what happens when we have parallel lines. Let's just connect PQ and choose another point somewhere on the coordinate plane. Let's put it right there, call it H. Now, if I construct a parallel line through H, you can see that its slope is going to be the same. So it's worth noting that parallel lines have the same slope. So let's make a note of that. Parallel lines have the same slope. Okay, now what happens though if we have a line perpendicular to PQ? What's the consequence for the slope there? Okay, well, let's take a look at what happens if a line is drawn through point H, but this time it's perpendicular to PQ. Now let's get rid of our rise and run here so it doesn't make it too confusing. So I'm going to take PQ and I'm going to construct a line parallel to H. I'm going to construct a line through H that's now perpendicular to it. Now let's see what we can learn about the slopes there. All right, well, calculating the slope of this perpendicular line shows me that I have a negative of the given line PQ. But is that just happening here because the slope of PQ is 1? Will that always be the case? So let's move Q and see if it changes the slope. Well, now my slope of PQ is 0.5 or 1/2, and the slope of the perpendicular line is -2. So that is not just an opposite, it's an opposite reciprocal. And if I change Q again, let's say I make it much higher, like the slope is now 3, I can see that the slope of my perpendicular line is -1/3. So definitely, it's clear that if lines are perpendicular, the slopes are opposite reciprocals. Now let's take a look at a couple of examples which apply some of these principles that we've learned about coordinate geometry and slopes. All right, suppose we had to find the slope of the median to AB. Now you know that the median to AB is going to come from C and it's going to hit the midpoint of AB. So it might not be exactly, but it's going to look something like that. So how do we calculate that slope? Well, the trick is to first calculate the midpoint of AB. So if we found the midpoint, and let's call it point D, we find that using the midpoint formula, which is the average of the x values and the average of the y values. So I'll add 2 plus 7, because those are the x values of A and B, and divide it by 2. And I'll add the y values, 2 plus 6, also divided by 2. And that gives me my midpoint of 4.5, 4. Then I'm going to use that new coordinate to calculate the slope of CD, which would be 8 minus 4, because those are the y coordinates, divided by 3 minus 4.5, which gives us 4 over -1.5. But that's not simplified. So I'll double the numerator and the denominator and get -8 over 3. And that's the slope of the median. Now how do we define the slope of the altitude to AB? Well, think about it. The altitude to AB is going to be perpendicular. So it's going to hit somewhere farther along and meet it at right angles. So let's first hide the median. And then take a look at what must be this altitude. Well, now it's not so important for us to find the coordinates of E, because I know that since CE, the altitude, is perpendicular to AB, the slopes are going to be opposite reciprocals. So I'll first find the slope to AB, and that's just used y2 minus y1 divided by x2 minus x1, and that equals 4/5. Now, since the slopes of perpendicular lines are opposite reciprocals, I simply take the negative reciprocal of 4/5, which is -5/4. Okay, there will be other problems in this exercises. I hope this helped, and good luck.